This is an introductory tutorial on LoopPro. So as you know, LoopPro is mainly a controller tuning software used for PID and other controllers. And this is, as I understand, initially developed by Professor Douglas Cooper at the University of Connecticut, and currently commercialized and licensed by Controller Station. So just to start with, I thank Controller Station, especially Dennis Nash, for allowing us to use this software and giving us free licenses for students under the current situation where all courses are mainly online. So a student may not have access to the labs, but it's our hope that through simulation, a student gets the experience of performing lab to some extent. Now to start with, when you open LoopPro, after installation, when you launch the software, you come up with this main window. Now, depending on your version, you may see something like LoopPro Developer or LoopPro Trainer. Just to make sure that the tab on the right screen, it shows the license information, where it's licensed under which institution. And if that tab, the writing are in red, meaning that your software is not activated yet. So if not, please collect the activation information and activate the software. Now to start with, if you look at the menu in the main window, the first file simply let you to exit LoopPro. There are modules which are case studies, custom processes, and design tools. And there are help for license management, or there is a help website called Control Group, and then some information about LoopPro. Now when you go to modules, there are these three items: case studies, custom processes, and design tools. These are also available from the tabs below. So this case studies, custom process, and design tools. We'll mainly use these case studies examples. So if you click on the case studies, you see a list of case studies that you can use. For the time being, suppose I take the case study for the gravity drain tank. So if you click on that, it will lead you to these modules on gravity drain tank. So all of this happening in this module is using the example gravity drain tank. Now under this module, you have again few menu items, like in file, you'll have how to save live data. You can open an already saved file. You can view and print plots. You can set the default folder where you want to save data and the default file name. You can close the case study or exit LoopPro. Under run, you can either pause an already running operation, or you can restart the process keeping the values already in place, or restart the process from the default value. And there is this, what is called this clock function. The clock function, using the clock functions, what you can do, you can either reset the simulation clock to 0, meaning the time will be starting from 0, and also change the execution speed, how fast or slow you want to run the process. That can be done. Under this task, one important thing is that there are always measurement noise, as these are done in these simulations. These operations are done in simulation, so you can change the measurement noise. And you can change the controller output value as well directly. You can change process disturbance, their value. You can change the set point. you can change controller tuning or change the step chart history, meaning that you can look at the last 15 minutes to like more than 4 hours. And then there are the help options, help from this control group, and then some information about LoopPro. What I found that is this, instead of using this menu item, this listed below, those really are the same thing over there. And you can use all these ones, and that may give you the direct access. For example, the clock is the same functionality that you can set simulation time to 0 or change the execution speed. You can do the rescaling of the y-axis or rescaling of the x-axis. Again, if you want to look at last 80 minutes or so, you can look at that, or you can rescale to the according to your need. The print will, if you click the print, it will print the current data window, so you can look at, and then you can save it for your printing or other purposes. I will go to the save edit later. At the pause, we'll simply pause the current operation, and then when you pause it, you can continue it again and keep it running. And then the design tool, that's one of the most important and mostly used tab that you'll be using, and I will show you in details what to do. Now coming back to the process, typically now all these processes have some sort of, we assume that you have some sort of understanding of this process. So what's happening in this process, that a liquid is coming in and it's going into tank 1, the outlet flow tank 1 is going into tank 2, and there is an outlet from tank 2. Also there is another outlet that can be controlled by using a valve. So we see a controller option here in the current setting. So controller is not in place. So now we need to check what is the control configuration here, meaning that you are seeing here the controller here, meaning that it's controlling the objective is to maintain the level of liquid in tank 2. Now by manipulating what? We see here, if you look at this one outlet from this, that for this case is identified as a disturbance. Okay. So and there is no valve here. So just by common sense, you look at that, okay, the only valve that you can manipulate is here. So control configuration should be in a way that the output is the level of liquid in tank 2 and input is the flow rate into tank 1. So if you really click it, you see the current setting, it says manual. So you can say PID to check whether the control configuration, what you're thinking is right or wrong. So you see that now it's connected to this valve, meaning that this is the input and this is the output. Again, check the terms input and output. Now come back to the data window here. It says the measured process variable. So that's another name of the variable output. And this is the controller output. What is the controller output? It is the input to the process. If you look at from the control feedback diagram perspective, it's the controller output is the input to the process. So for this case, this one is the input. What is the controller output is the input, and the measured process variable, that's the output. So you know the control configuration. So for the time being, we'll keep it, say, under manual mode. Now going back to data saving. Now LoopPro, when it runs, it does not save data by default. Just remember that it does not save data by default. So if you look at this save option, if you click it, then it will ask you where you want to save your data. So you can save whatever folder you want to save. So suppose for my case, I have a data file already, and I want to say, suppose, say gravity drained tank data. Now you can just give it a date stamp, and that will start saving data. Now when you start saving data, it says you that what is the storage rate. So by default, it saves every 9th point, meaning that the process may be collecting, in the process there are so many data coming out, you may not save all of those. So suppose I say every 3rd point I want to save, and it said reset simulation time to clock to 0, and by default it will do it, and then stop saving. Now, how do you know that? Okay, it's saving that when this button now shows a cross red sign, which means that it's saving data. So if you click it again, it will stop saving. Suppose I want to start saving data, then I'll be just simply using this thing running. So it's saving data. So what I can do, I need to look at if I say, suppose make a change in the controller output. So it's now under manual control, so you can manually change the valve. So I say I make it from 70 to 80. How does it look like? Now you can see here the input went from 70 to 80. These are all the valve opening percentage, and the level of liquid in the tank too went this way. You can pause, you can look at the response, or you can do some, say how much data you want to see. Okay, you have this over there. Now you say, okay, if I bring it back to 70, what happens? Click 70 and then continue. Then you see it's going like this. You want to rescale it to look at more of the data. You can see it. And then from 70, if you go back to suppose 60, what happens? You see the level is going down. So again, if you want to bring it back to 70, it's coming back. So we have the data set so far. So we can think of a way. I have enough data, so I can simply stop saving. Now when you stop saving, it's also keep on running, but it's not saving data anymore. So you can pause it to do further analysis of whatever you want to do. You can look at the edit file option, and then suppose if you want to open this file, whatever I saved, if you do it, you see some file coming here, something like this one. Now you need to know which variable is what. So here it says the time in minute. So it's, although this looks like the numbers are quite very different, that doesn't matter. The time stamp will be simply something like that. The controller output, which is really the input to the process, and somehow it was not exactly 70. Okay, maybe this is a simply numerical issue. And you see the process variable, that's the output, that was initially at around 4, and then went to some other values or whatever. We look at the plot. The set point, because now it's not under control, there is no set point, so set point is exactly the same as the output value. The disturbance variable, which was for this case, this outlet flow from here, was just 2 liters per minute. Okay. Now along with the valve opening, it also showed you the inlet flow, how much is the liter per minute. So for this, for our cases, we'll just simply relate it to valve inlet to the output flow. So we'll consider this valve opening to be the input variable. Now we have collected some data. Then what you want to do? You need to find a model, and then you need to tune a controller for this process. So if you want to do that, you'll have to open this what is called this design tab. If you do it, it shows all the different options you have to design a controller and implement a controller. So for this, starting with, you need to first open a file. So if you go to, suppose in this file, you open it. So it shows the variable names. So I need to make sure that all the data are there. So it looks like they are. So you click OK. Or you can look at the statistics of the data. So if you click on Stat, it will show some statistics about the process. So it's showing the process variable, what's the minimum, what's the maximum, what is the mean, what is the variance, and other statistical properties, including how many data points are collected, including the graph. Okay. So there are some other aspects which are maybe a little bit more advanced. So for this tutorial, we will skip those. Just if you have these variables there, so you can change the minutes from seconds or milliseconds, whatever you want, or hours. I'll keep it as minute, and then select OK. That's my selected data point. Now I can view the plot. So that will show me the entire plot. And under this plot option, this may be very useful because you'll get this data with a certain background, which may not be the most suitable for printing. So what you may want to do, you can go to, say, you can also rescale it. For in this case, no rescale is required. You can also zoom in. So for this case, this color option is important. So it shows that the viewing style is color. You can make it monochrome. And you can make the line style to be changed if that fits your output for printing or putting it in a PDF file or a Word file. Also for these variables, you can choose the minimum and maximum. So for this case, suppose I have up to data point, say around 40 or so, I don't have any information. So maybe I can set the minimum to be 40 and maximum whatever value is there. Say suppose I want the maximum to be 150. So major tick mark can be suppose 20 and the minor tick mark can be at 10. All of the x-axis level. So let's see apply changes. So what happens that I have now something with a white background that may be suitable for putting in a Word file. So take note of that. So I have this done. And I need to accept and close. Okay. So now you want to find a model from this data. Now what you can do, you need to first select the model. For most of the cases, we'll be selecting what is called a first order pass date time model. So that's the default setting also here. So if I keep this checked, there are other options as well if you want to fit a second order model. So you can do that and it's done. And then you have to simply click start fitting. Now when you start fitting, it already did the calculation and find out the model parameters. For first order model, the parameters will be the gain, the tau or the time constant, and the theta, which is the time delay. And here shows the model parameters as well. So you can do a little bit of tweaking in the model, see whether it improves or not. So here the R-square value is shown, and also like the percent deviation is also shown for these cases. Now, what you may want to do, suppose you want to select the model based on one-step test. So that's one approach. Because you see that the yellow line here is the predicted value from the model, and those line like below that was the white line, those are the real value. And you see that there is a little bit mismatch. Why is this? You will learn that because of non-linearity in the process, it's not like the for step in, step up, and step down, the gains are not the same. So what we want to do, you have to see that okay, there are lots of information here. Before the step test, these are steady state values, so these may not be valuable for doing the finding the model. So you can simply drag this line here, and it will re-estimate the model parameters. Now for you maybe, you may not have this option under trainer. If not, you can simply change the values over here. So you can say the values to be whatever t start or t end. Okay. So let's see, or you can, if you want to use only one step, then you can really drag it over here to use only this one, and you can also zoom in for that part, and you see that, okay, no, I don't want to use this all of this flat line as well. You can simply use only this part and only this part. So now it's using the most appropriate information to find the model and trying to fit there. Okay. So again, you can like go to the plot option and then change it to whatever way you want. You can have a main title, you can have a subtitle, if you want border or not. Also you can do monochrome or monochrome plus symbols. Apply. You see, if you don't like the symbols, you can simply keep the monochrome format, apply, and see how it looks like. Okay. So there are lots of options to play with. So you can just play with the options there and check which best suit for your purpose. So I have a model now with a gain of 0.1336 and the time constant and the time delay. Now, what you want to do, you can accept and close. You have the model there already. Now, what you may want to do, you may want to design a controller. Now, when you say accept and close, it automatically brings you to this window where it has already designed a PI controller for you. So there are options for proportional only controller, there are options for proportional integral controller, there are options for proportional integral derivative controller, and there are options for PID with filter. Suppose we want to implement only the PI controller. Now, before implementing it, we need to look at the response. So I see that if under this controller, if I have a set point, the yellow line, the response will be something like this, and the input value will be something like this one. So I want to make this controller a little bit more aggressive so that it takes actions quickly. Okay. So for doing that, I can play with this, and in the trainer version, if it's not available, then you can play with the closed loop time constant parameter. So if I say closed loop process to be faster, instead of 5, I say 4. Let's see how it goes. So it's designing controller, so I see that the response a little bit faster. So I want to make it faster. I can make it more aggressive and see how the response looks like. So to me, it's looked like up to this point, it's good enough. So I have a little bit what is called this overshoot going on. So it will go beyond the limit and coming back, but the response is quite faster, so I'm happy with that. So what I can do, I have this controller chosen, so obviously the model parameters are there. So everything is, so the closed loop time constant is now 0.704 minute. Initially it was around 5 minutes. Okay. In the PID response, you can look at this. Now we can implement this to the process. For doing this, you simply implement. So implement to the gravity dependent process, and so you want to the PID controller is the PI only we designed. Then you are say done. There are other control options as well. So DMC, we will not go into details for these cases now. So you say implement, and then you go to the process and make the controller PID. You see those values has already been here. So done. So now if we make a set point change from 4 to suppose 5, what happens? You can look at the response. So you see, like the under control, so the process is bringing back to the, so you made a change in the set point, and process is bringing back, taking the output to the desired value within short time. Now you want to save this data, so you're going to save it, you want to save it again. So you say close loop data. Again, I say stop saving with the 3 points. So if you continue running, and you make it just set point for 5 to 4, you see that the process brought back to the desired value by the controller. So that's what is called this, what is called set point tracking or servo control. There is another aspect called regulatory control. What is that? If you want to make, say, the disturbance changes with time. So suppose the disturbance changes from 2 to 3, meaning that the outlet from this through this valve is being 3 liters per minute now, whether now we still want to maintain a level of liquid 4 in this tank. So if we make that change, let's see whether the controller is able to bring back the process to that value or not. So I make it change from 3. You see that although the disturbance change, the outlet flow is now more, the controller has increased the inlet flow to maintain a level of 4 here. So within a short time, it has been able to brought back there. So I save my file and then stop saving, so I have the data for that. So in brief, so what this tutorial showed you is that you can use this software to do some what is called this test, meaning that you can change the input variable in a certain manner. I only showed the step change, but there are ways to make change as sinusoidal signals as well, or the what is called this random binary signal. And then you can use the data to find a model. Then you can use the model to design a controller and then implement the controller and look at the closed loop response. Okay, so that's the use of this tool. So what I have covered, that's more or less covered throughout the course, the different steps, how to do testing, how to use the data to find a model, and how to use the model to find a controller, and then how to implement the controller to look at what is called this closed loop response. So in this tutorial, we have covered all of these aspects briefly. However, there are other utility of this tool as well, where you can have some sort of advanced controller and that can be implemented. So please take a look at all of these options and just use whatever is more appropriate for your case. Thank you.